This is a demo showing voice control of infrared controlled devices using the Voice for IoT app, a Global Catch IP to IR hardware device, and IR codes emailed from the Global Catch control tower database. I will cover setting up the iTach, parsing emails received from the Global Catch control tower database, sending a single IR command. I will cover setting up Voice for IoT groups to work in sequential execution mode, which could also be referred to as a scene in another video. I will be using the app on a local network, so I will need to add a local network in the app. This is needed as the app supports multiple properties and hubs, and we want to be sure we are connecting to the correct device when sending commands. If we were connecting to a dual band or multi-band router, we would have needed to add multiple local networks for each frequency. I will now link the iTach in the app since I have not changed any of the default values. I'll leave those as default. I need to associate all the local networks on which the iTach resides. Before I add our first voice command, I will obtain IR codes from the Global Catch control tower database. I need to grant access to files on the device as the Voice for IoT app will be writing all of the IR codes to a CVS file. This is done on local storage, as it would be very unlikely that we use all of the IR codes obtained from the database in the app, and we want to keep backup files for the app as small as possible. Access to the local storage is only needed when adding new voice commands or parsing emails. So if we would like to revoke access once both of these items are completed, we can do so. And we now have an empty folder called Voice for IoT. This button provides a link to the control tower database. Once the desired codes are located, they will be emailed to the user. I have already obtained a couple of IR codes via email. We now need to add the bodies of the email into the app so they can be parsed into a CVS file. In the Gmail app, we can easily tell if a file is too large for sharing by looking at the three dots. Well, looking to see if there are three dots at the bottom of the bottom, at the bottom of the body of the email. So this set of IR codes is not too big. However, the set for the Samsung TV are too large for sharing. So first I'll add the codes for my Pioneer receiver because it did not have the three dots on the bottom, so I can directly share this to the Voice for IoT app. And as we can see, there are not 3 dots on the bottom indicating that all the data was shared to the Voice for IoT app. I now have the IR codes in a data format that is easier for both the app and the user to read. I'll now show adding IR codes for emails that are too large to share. And again, we have the 3 dots at the bottom here. So we'll look at the entire message, that way we get all of the IR codes. We'll select the entire body, and if we were to share, not all of the data would be moved over. So in this case, we will need to copy. As we can see, the 3 dots are not present. And we now have both the Pioneer and Samsung codes available to us. I'm now ready to add a linked voice command. This will be the TV in my living room. We could automatically add all of the buttons as spoken actions, but this may also cause conflicts between spoken devices with the spoken actions, so I recommend adding them manually. But as we can see, they're all available in the app. We now have a device called Living Room TV with which we can associate actions. I will now associate a spoken action to an IR code. The link command is Living Room TV, and the action I want to associate is on. I can see that I need to grant access to record audio in order to use voice commands, so I will do that now. Turn on the Living Room TV. Turn off the Living Room TV. I can see that I need to associate the spoken action off with the Living Room TV also. turn off the living room TV. This concludes the simple setup for the iTach. I will show how to use groups or scenes in another video.